So here I have added few information apart from this power budget. So what I mentioned the designator of each and every component and what is the net name. So for example, between DC jack and diode, there is a net which is net D3 underscore A. So if you already watched level 1, you have understand like why I am putting these net names here, because we need to enter these information with voltage and yeah, we have to define each and every net, each and every power net on PDN tool. So that's why I've entered everything. And this is our block 1, block 2 and block 3. This particular block, which is DC jack and plus 12 volt, this will be common for 1, 2 and 3 circuits, and we're going to simulate these one by one. Alright, so let's open Altium Designer. I've opened same files on two things. I'll tell you why. So let's open that. Okay, go to the tool and click over PDN Analyzer. Okay, so this is our DC net identification window, and here we have to select each and every net. So these are all the net names, right? Let's choose them one by one. So firstly, these are pretty much straightforward, and ground will add selected, right? So this is 5, 5, 5, 3.3, 3.33, 12. All right, now we'll see what are the nets. So these are done, this is done, ground is done. We have to enter net D3 underscore A. Alright, so for that we have to enable all net for filtering, and here we have to see net D3 underscore A, right? Let's see. Okay, this is the one. Now it is asking for what is the nominal voltage on this one. So that's why you can see it is 13.25, right? We have already calculated. So it will be 13.25. Add selected. It's added here. Now we'll check another net, which is net D3 underscore K, which is 12.25. All right. D3 underscore K, and this is 12.25. Add selected. Okay, so this is done, this is done. Now net FB1 underscore 1, which is again 12.25. all right, FB, okay, this is the one, and it is 12.25, and add selected. So this whole nets, this particular net for this network is done. Now we're going to select these nets. And here we are considering the voltage drop or the DC resistance of these inductors are approximately 0, because inductors are directly shorted, right? So here we'll assume the same voltage as output. So this, but yeah, when we'll be putting this information, a series component L1, we have to define what is the maximum current can pass through this inductor. All right. So another net is net C21 underscore 2. All right. C21 underscore 2 and C22 underscore 2. All right. So net C21 underscore 2. Okay. And this is for 3.3 volt. And C22 underscore 1, this is for 5 volt. Okay, let's verify that C22 underscore 1, because on block it is mentioned underscore 2. So for that, that's why I've opened this this one. So what we'll do, we'll just hover our cursor on this location. It is net C22 underscore 1. Okay, so we are doing correct, and we'll select that as well. Okay, now we'll move to third block. So here we have C34 underscore 1 and C35 underscore 2. So C34 underscore 1 for 3.3 and 335 underscore 2 for 5. Okay, before adding those, let's verify that as well. So this will be C35 underscore 2 is for 5 volt and 34 underscore 1 is for 3.5. Okay, this is also correct. Add selected. So we have added all the nets, right? Now press OK. All right. Now we'll go to file and click over this compact layout. Before starting anything, we'll just save this file. So this is our network 1. All right. Now what we'll do, we'll go here and we'll start creating this block diagram, which is this one. Okay, this DC jack, 2 diode, switch, farad beads and 12 volt. All right, let's do that. So before that, we have to define the net name here. So here, edit net, and this net name will be net D3 underscore A. All right, and this net will be ground. You can also double click on that. Now we're going to add source. Our source is J4, which is this one, right? Okay, this is fine, this is fine. I out max from a source. So I know I'm going to add a supply, which is 30 volt, 5 amps, right? And in our case, the voltage will be 13.25 input voltage, and it can able to supply 5 amps. So this will be 5 amps for my case. In your case, if you are using some low supply or some adapters, mention that maximum current rating. All right. Now we're going to add. So let's open that. I'm just doing it really slow because this is the complex part I was talking about. Creating a power budget is kind of similar thing at level 1. But yeah, this is a quite difficult, and you have to go really slow and understand each and every step. All right. So now we're going to add diode here. So for adding anything in series, we'll click over. So we have to just right click and extend it. Now what is the net that you want at the other side of the diode, right? So for example, here you have to select this net, all right? In which net you want it to extend, right? So this is D3 underscore K. Okay. So this is our diode. Now we'll double click on this and define all the properties. So this is our D3. Now what is the voltage drop across the diode? It is 1 volt. What is the resistance? It's not required. We already mentioned voltage drop here. What is the maximum current that going to flow from this diode? So that you can choose from this thing, the data sheet of diode. So in our case, it is 1 amps, right? So I'm just going to enter each and everything as per data sheet. I'm not going to put any random stuff because we'll get biased result at the end. So let's put all these information correctly. Okay, if you are not sure, just open the data sheet and make sure you are entering correct value. All right, so this is 1 volt drop and 1 amp max current diode. Now we're going to put another series component, which is a switch, right? So extend net to FB1 underscore 1, right? So FB1 underscore 1. Now this series component is a switch, right? And for switch, voltage drop is 0, maximum current don't care because I know it can able to handle that amount of current. All right. Now we're going to extend again, and that will be the property of farad bead. So extend it, and this will be 12 volt, right? And this is our farad bead. So here, as you can see, we can choose either FB1 or FB2 for as a farad bead because these both are connected in parallel. So you can't add multiple parallel component here. So you have to calculate all these values together, right? So that is what we did in our power budget. For now, I'm just going to choose FB1. And here we have to enter voltage drop. So go there what was the voltage drop across this? It was 0.25 volt, right? So we'll enter that 0.25. What is the resistance of this one? If you'll again open that, it was 150 milliohm, 300 milliohm each, small m. Okay. And what is the maximum current through this farad wheel? So again, we'll open the data sheet of that and we'll see. So go there, here, just copy the manufacturer part number of this one, open Chrome, and go to the data sheet of that, or maybe it is mentioned here. So current rating max is 500 milliamps. For each we are using 2, so maximum current rating will be 1 amp. See, these all things are going to fail. We'll see. So this is 1 amp. Okay. So till here we have defined all the parameters. Now we're going to add load. So if you open our block diagram, what is load for this first network? This is the one, right? TPS 8214, right? This is our load. But we're going to use 2 chips, U1 and U2. So we'll add 2 loads here. All right. Add load. Now from here you have to select SMPS because we're going to use a switch mode power supply. All right. Now output will be this one, right? And chip will be U1. Out 1 will be 3.3 volt. R out is not given there. What is the efficiency? Efficiency is 89%. So this will be 9. Fixed input current. There is no fixed input current. Okay. I out is fixed, which is 2 amps, right? So let's verify that it's for 2 amps on both channel. And maximum power pins current. This is again will not enter anything. So let it be don't care. This is our channel 1 or first load. Let's add another load, which is again a SMPS. This will be U2. This will be 5 volt U2. Here we'll enter 5 volt. This efficiency will be 92%. So let's enter that 92. And what is the output current? It's again 2 amps. We have entered all the information. Press OK. Now we're going to add, because these are again a further regulator, right? So that means till now load is not defined. See, it is so showing load 1 is invalid. I mean both of the loads are invalid, but it is showing like that. But these are done. Now what we'll do, this for U1, this for U2. Let's click on this one and we have to click. So what I did, right click, add VRM to new network. We'll do that. Okay. Similarly here we'll do add VRM to new network. So now we have created a new network of 3 volt and 5 volt, right? And here load will be, add load our J1. Okay. What is the load current? Max. What will be the voltage you want? So I want in the range of plus minus 5%, right? For 3v3. And here we'll add another load, which is again on J1, and this will be again max current plus minus 5% of 5 volt. Now we'll click on file, save, and this is our block 1. File, save, block 1 PDNA. Okay, this is done. Now we're going to add another network. Okay, this is added on this only. File. Now we have to click on new simulation. Okay, So this is one simulation, this is another simulation. Here also we have to create this first part, right? We can't copy and paste here, so I'll just quickly create it, and yeah, then we'll enter the two channels of another block, which is TPS 5489. All right, so let me create it quickly. All right, so till here we have added the same network. Now we're going to add load, but in this case our load will be this IC, which is this one, U3. Okay, and here on channel 1 we have 3.3, and on channel 2 we have 5 volt. All right, so let's enter our load, which is U3. Now this will be connected to inductor. Okay, so this inductor will be L1, and its net is net C21_2. Okay, L1. All right, so this will be our output, or you can directly connect it to 2 volt. Okay, so here let's mention this output 3V3. What is the efficiency on this channel 1? So on channel 1 it is 92%, and maximum current on channel 1 is 1.5 amps. Press OK. Now we'll add another load, that will be our channel 2 for same U3. This will be 5 volt 2 of L2. Here enter 5 volt, and efficiency is 80%. You can see from block diagram. What will the maximum amount of current will be 2.5 amps, and press OK. Okay, so here we have added these two more loads on this one. Now what we did, we have added further network on this load, so let's do that. Okay, now we'll go on first network, we'll add load, and that load will be our another connector, which is J2, right? So we'll click on this one, we'll go to J2, right? What will the load current on J2? It will be max 1.5 amps. Minimum will go for ±5%. Similarly, here we'll add another load, which will be on J2, plus here the current will be 2.5 amps max ±5%. Okay, file, save. Okay, so we have created two separate network, and whatever you want to simulate, we'll just check here and you can able to simulate it. Now we'll add another block, so let's click on new simulation, and here I'm going to again create our common block. So give me some more time. All right, so here we have added our another block. Let's save it. Now what we're going to do, we'll add our load, that will be another buck converter, which is LM26400Y, and here also we have two channels for 3V3 and 5 volt. Let's add those quickly, and we have already noted down all the nets on block here, so let's do it. So add load, that will be SMPS, this will be U4, and out will be 3V3 first. 3V3 is connected to 34.1, which is L3, and here the voltage is 3V3. Efficiency we have to check, which is 85%, and the current is 2 amps. Sorry, here it will be 0, here it will be 2, right? We are not taking it fits input current, so that's why. Press OK. Now we'll add channel 2, which is again a SMPS U4. This will be net C35_2, and this will be connected to L4. Please enter 5 volt, Let's check the efficiency. It's 89%. Now enter maximum output current. So in our case that is 2 amps for both channel. So let's enter that. Okay. Now what we did, we'll just add VRM to new network, right? And similarly we'll do for 5 volt. Okay, we made some mistake here, I guess. Double click on this one. Oh shit, here we have mentioned wrong net name. So this happened. So for that, what we have to do, we have to delete it. So firstly remove this, go there, delete this. All right, now add load. See, this happened, and you know how to redo that, so it's okay. Now here you have to select correct net name for 5 volt, which is 35 underscore 2, or this one. This will be a 5 volt. Efficiency is 89%, I guess. We'll verify one more time. Okay, yeah, it's 89. Let's go there. 89. Here enter, it's 2 amps. Press OK. Now right click here, VRM. Now it's fine. Alright, so let's add load here. So add load, which will be our J3. What is the load current? 2 amps max plus minus 5%. Here also add load, 2 amps plus minus 5%, J3. Okay. All right. So stage is set. Now we have to do analysis of each block one by one, and we'll see where is the. So during simulation, we're going to take care of following points. What will include in PDNA report? First thing, maximum current density will include at which point there is maximum current density, and will include 3 points of current density in decreasing order. Okay, that will be our first observation. Second observation will be voltage drop, and similarly will include 3 points of voltage drop in decreasing order in our report. Third point will be where it is failing. So when our simulation fails in term of series component or whatever the properties that we have defined, we'll take a snapshot of that as well. And although when we'll generate a final report, it will be included there. So we're not going to resolve anything on this one. Okay, I'm going to discuss these report in very detail on upcoming sessions. But yeah, and if you want, you can tell me what will be the solution of different fails in comment section. Okay, for 4 thing we'll take a picture or a snapshot of minimum current density and minimum voltage drop, and we'll generate a complete fail pass report. So these are the following things we'll include. Let's start with the simulation of block 1. Okay, so we'll just check block 1 and we'll see analyze. Confirm batch analysis. Okay. All right. So why it simulated this part? Okay, anyways, leave it. Okay, so here you can see as a result these few information, whatever we have entered is failed. So here what is failed, if you'll hover here, actual voltage is 1 volt, okay, which is fine. Actual current is 1.557 amps. But what is the amount of current that diode can able to handle is 1 amp. So we have to change this diode to some higher rating diodes. That is a one thing. Another same thing for farad bead, because the current is flowing in series, and this farad beads whatever we have connected can't able to handle that amount of current, because these are just 0.5 amps farad bead, right? So what is the amount of current flowing from those two parallel farad bead is 1.557 amps. So this is again another fail. Okay, so we'll just save this simulation. Now we'll go to visual inspection of that. So for visual inspection, so here these are the simulations which are kind of passed, but this one is failed, and where it is failed here. But what we will do, we'll go to visual one. Okay, and we'll click on 3D overlay. All right, and we'll convert that to displayed. So this is for voltage, and here you can see I found something which is related to voltage and current. So let's we'll not do anything, we'll just capture the maxima part. Okay, so this is our maxima, and second maxima is where it is. Okay, it's all there only. So what we have to do, we have to press shift, and if we'll just, oh hold on, no, control Z, no, all right, shift, and if we'll go there, there is a pad, right? This is the pad, and on this same pad you can see all the three maximas are there. Okay, what happened? One, two, three. It's on the same section. Okay. So let's capture that waveform as well. So for first one, it's on the top layer. So how to capture this thing? What we'll do? Let's label that first. Okay, this is fine. Now we'll go here. Here all the designators and everything is visible. We'll take image capture. Okay, what will the point of this image? It is max VD or voltage drop underscore 1. Okay, done. And second and third are also on the same point, so we don't need to take multiple same screenshots. Okay, but yeah, we have captured this thing. Now we'll go to current density, and we'll see where is maxima. So maxima is somewhere here on this particular net, which is on ferrite bead. Okay, so this is our first maxima is here on diode D3. So let's capture image, and this is current density 1. Okay, done. Second is on this location, so we'll again image capture. This is current density 2. Done. And third is this section, which is, and here we are getting the value as well. So as per IPC standard, what will be the value of these current densities? Okay, we'll see. If we are passing those, then it is okay. If we can't able to pass those, then we have to increase the thickness of tracks, right? So image capture, this will be current density underscore 3. All right. So these are the waveforms that we have captured for maxima. Let's see where it is minimum. Let's see minimum on this ferrite bead. So let's capture at that as well. So capture image. This is CD min. All right, done. And voltage minimum is somewhere here. Voltage drop. So image capture. This is voltage drop minimum. All right, Cool. So we have captured all these waveforms here. These are the sliders. We don't need that. I've already told you on previous levels. All right. So for these discussions, which one is critical, which one is not, for that we'll just generate the report, and later we'll read the report and see where it is failing, right? So for generating the report, we'll again go to visuals, click on report. Okay, so we want a report for one and this one. Okay, and you can, these are all the images that we have captured. All right, close, generate report. Okay, so this is our report of block 1. Cool. Now we'll go back, go to configuration, we'll uncheck this one, and we'll simulate block 2. Yes. All right. So here also we are getting couple of is out of date, regenerating it. Begin analyzing block 1. Okay, this is the one. Analysis complete for block 2, found violation. Okay, so there are a couple of violation found on block 2. What are these? So I guess it's same violation. Okay, so here it is failing because this will fail for all the blocks, right? We have to change these two components, but again we'll capture the waveform as per discussion. So we'll go to overlay 3D, right? Sorry. Okay, so this is our 3v3, this is 5 volt, which is kind of okay, and this is our main network, right, which is connected. So this we have already taken, right? Let's check on this one. So here I found couple of red section, which is so much red, almost 100%, and similarly on 5 volt. Okay, so we'll capture on these two network. So go to visuals. Here I guess we have via, right? So some component is on bottom layer, and through via it is coming to top layer, and that is high current density. Okay, we'll capture that. So on this one we'll just go to maxima and see the current density is really high on this one, which is okay, that is for voltage. Voltage is fine, it's max. We'll see for minimum voltage, which is here. That is again 3.28 volt out of 3.3, which is again fine, right? We'll capture the current density only. So where is maximum current density? It's there. Image capture, block 2, current density, max, capture 1. Okay, capture 2. Okay, this is fine, it's 23 amps per mm square. I guess the maximum current density as per IPC for a particular track is 70 or something. That I have to verify, but that will do during our report analysis. Okay, so I'll create a separate tutorial on that, and we'll discuss and we'll resolve all this issue. Otherwise this will be like really big, but again you can able to understand what will the resolution of this high current density part. We have to increase the track thickness on our design. Okay, and I can show you, right? Okay, hold on, I'll show you. So in 2D, if I'll select this track, okay, why can't I select it? If I'll make it, let's suppose 50, Okay, I've selected something else here. Control Z. I guess we have to go back and select. Leave it for now. I'll do that later. All right. So we have captured first critical part here, and on this one I haven't found anything critical because whatever the thing which was suspicious or where we are getting errors on this section. Okay, so that we have already captured on block 1 report, and similarly you can do this analysis of block 3, right? It's already done. I don't know how I haven't selected that. Okay, maybe it's some bug, but again it's done. So on that one you can see again this particular first thing, which is these two things. If I'll show you one thing. Okay, if I'll change that, double click on this one, if I'll make it 1.44 or 1.7 or 2 amps, if I'll pick some diode of 2 amps, okay, so you can see this is resolved. And similarly here, if I'll pick some ferrite bead of 2 amps, 1 amps each, this will be also resolved. So these things are resolved now. And when I'll do analysis again, the only things which I have to change is this pad size and this track width. I guess then after this thing, it will be fine, right? So these are the couple of changes. I hope you got my point, and it's really easy to analysis this, because most of the analysis we did on paper as well. So what I am talking about these voltage drops and talking about the maximum input voltage. So this we already did on paper, but generally what we assume we're going to put 12 volt supply with all these series components. Then we'll see we are not getting enough voltage for regulators and all those stuff. So that is again a kind of a blind simulation that we have to do. But yeah, I mean, we are aware of some drops here. So we have already mentioned the voltage for each and every point very correctly. So that's why we are not getting so many errors. But yeah, these are the errors related to tracks and we have to resolve. So I hope you got this complete tutorial. And on level 3, I'm going to increase it a lot. So that will be really complex, especially this PDNA inputs and its simulation will be really complex. Yeah, let's see you there, and we'll learn a lot from these series. Thank you.